Welcome to This Explainer. Today, we're diving straight into how NVIDIA is completely reshaping the future of personal computing. I mean, we are looking at a massive hardware leap here, one that bridges the gap between the trusty computers we've known for decades and the truly intelligent machines of tomorrow. Look, if you've been following the insane, rapid advancements in AI lately, you already know the hardware absolutely has to keep up. But here's the thing. It isn't just keeping up anymore. It's setting an entirely new foundation.
So let's just jump right into this. NVIDIA's stated goal is to reimagine the PC for the first time in 40 years. 40 years! Just think about that timeline for a second. The traditional computing era, the fundamental way we point, click, and interact with desktops and laptops, has relied on the exact same basic paradigm for 4 decades. But because AI is demanding so much power, that era is officially evolving. We're not just, throwing more RAM in our machines anymore. We are fundamentally rethinking what a personal computer actually is from the ground up.
And that rethinking brings us to a really fascinating question. What actually becomes of our personal computer in a world of AI agents? Take a second and just picture your daily routine. Think about all that friction. Switching between tasks, hunting for buried files, sitting there waiting for cloud apps to process your prompts. For things to change, your machine can't just be a passive tool sitting on your desk anymore. It has to become an active, intelligent participant in your workflow, offering continuous, proactive assistance.
Which brings us to the AI agent. Now, to be super clear, we aren't talking about some random chatbot you open up in a browser tab. No, we're talking about a personal AI running continuously and natively right on your machine, just getting work done in the background. And the absolutely crucial part of this is that it's securely sandboxed. Since your personal AI operates directly on your device, all your data, your personal habits, your private files, they stay perfectly secure. It's all the intelligence you want with literally zero compromises on privacy.
This setup creates a brand new hybrid computing approach. On one side of the coin, you have local models running directly on your device, giving you that lightning-fast, sandbox privacy we just talked about. But then, on the other side, you have cloud models ready to handle massive external processing whenever you need to tap into larger networks. So the PC of the future? It isn't forcing you to choose between local or cloud. It seamlessly integrates both, automatically picking the exact right tool for every specific task.
But here's the catch. To make this agent-driven dream a reality, the chips and the operating system simply must evolve. The legacy hardware we've relied on for so long just has to be left behind. I mean, you can't run continuous, sandboxed, hybrid AI agents on an architecture that was originally designed for basic word processing and browsing the web. The infrastructure itself literally has to be rebuilt from the silicon up to handle a constant, heavy stream of neural processing.
And that brings us to NVIDIA's massive solution, the RTX Spark. Guys, this is not just another standard product refresh. This single chip represents the total distillation of 33 years of relentless hardware learning and mastery. NVIDIA has basically taken every single lesson they've learned from graphics processing, from data center expansion, from AI acceleration, and engineered it directly into one unified piece of silicon designed specifically for your desk. All right, let's hit the specs, starting with this awe-inspiring number, 70 billion. They have somehow packed an incredible 70 billion transistors onto this chip. To actually pull off that kind of density, NVIDIA is using a cutting-edge TSMC 3nm process. Now, to put 3 nanometers into perspective, get this. A single strand of human DNA is about 2.5 nanometers wide. By shrinking the architecture down to near biological scales, they're fitting just an immense amount of computational power into an incredibly power-efficient, physically tiny space. It completely changes the physics of what your home computer can do.
Keeping the momentum going, let's talk about the graphics engine driving this beast. The RTX Spark features a Blackwell RTX GPU armed with a massive 6,144 CUDA cores. For the hardware fans out there, you know that CUDA cores are the heavy lifters for parallel processing, which happens to be exactly what AI workloads eat for breakfast. Having 6,144 of them working in perfect harmony means your machine can just chew through complex agent tasks, heavy rendering, and complex mathematical models at absolutely blistering speeds.
But of course, immense processing power means basically nothing if your system is choking on data transfer, right? So to make sure there are absolutely zero bottlenecks for your AI, the RTX Spark boasts 128 gigabytes of unified memory. And that word unified is key here. Because the memory is unified, your CPU and GPU aren't wasting precious time copying data back and forth. They both access the exact same massive 128 gigabyte pool instantly. This allows giant AI models to sit directly in memory, constantly awake and ready to assist you. And all of these crazy numbers, the 70 billion transistors, the 6,144 CUDA cores, the 128 gigs of unified memory, they all combine to deliver exactly one petaflop. That is 1 quadrillion operations per second. Hitting 1 petaflop natively on a personal computer is just an astronomical leap forward. To put that in perspective, a petaflop used to require a literal warehouse full of supercomputers, and now it's sitting quietly inside your PC, powering your daily workflow. It's almost hard to wrap your head around. And the architecture of this hybrid powerhouse goes even deeper. NVIDIA didn't just stop at the unbelievable capabilities of that Blackwell RTX GPU. Nope, they actually partnered up with MediaTek to fuse it with a custom 20-core Grace CPU. And the secret sauce tying this whole thing together? NVLink. NVLink is this ultra-high-speed connection that lets the GPU and CPU communicate so incredibly fast that they essentially act as one single unstoppable brain.
Okay, let's pivot to the software side for a second, because amazing silicon needs an amazing operating system to actually use it, right? This is why we're seeing a massive, super close collaboration with Microsoft. They are working hand in hand to architect a Windows platform specifically designed for these AI agents. The OS will inherently understand how to perfectly route tasks straight through the RTX Spark, making your personal AI a native, deeply integrated part of your everyday Windows experience.
So who is this massive technological leap actually for? Well, NVIDIA is targeting 3 core pillars here: creating, gaming, and agents. Whether you're a creative pro rendering huge 3D scenes, a hardcore gamer who demands hyper-realistic, physics-driven environments, or honestly, just a professional relying on smart AI agents to manage your life and get work done, this hardware is explicitly built for you. All of this data, all these specs we've covered today, they all point toward one undeniable truth. We are looking at the dawn of a new personal computing revolution. This is not just some iterative upgrade where, your apps open a fraction of a second faster. The RTX Spark is a fundamental pivot in our relationship with machines. The PC is transitioning from a passive tool waiting for your command to an intelligent, active partner working continuously right alongside you. As we wrap up this explainer, I really want to leave you with a question to chew on. How will your daily life actually change when your personal AI is continuously working for you? When your computer has the equivalent of a petaflop of brainpower securely sandboxed right at your desk, what entirely new levels of creativity and productivity are you going to unlock tomorrow? The 40-year paradigm has officially shifted, guys. Now it's totally up to us to see what we can build with it. Thanks so much for learning with me today.